Now, dear students, chapter number 10 Mechanical Properties of Fluids. And today we have the topics for the discussion. Those are based on the concept of the Bernoulli principle. And today's we have the topic blood flow and heart attack, including dynamic lift, spinning of ball, aerofoil, that is lift of a aircraft wing. Uh, so how these are applications based on the concept and how can we apply the concept of the Bernoulli principle. So here we will discuss all the applications one by one, and already we have discussed the two basic applications. Those are associated with the Bernoulli principle, like the Torricelli law of efflux and the Venturi meter. And as we are just discussing the blood flow and heart attack, how it's come. Now, as I am just showing the portion of a artery which associate with the heart, and what is the role of the heart, if I am just saying to you, because so many bio students are there, so they can easily give the answer that heart is providing the blood to the different parts of the body, okay, through the artery. So how the blood flow is affected and creates the heart attack. So here we are just explaining this one with the help of a some that imaginations in the diagram. As I have just imagined, the one of the heart is that which providing the blood flow through the artery. If everything is normal, if you are not that only if you are not watching this one section, so everything is normal, so there is a normal blood flow is there, and as the normal blood flow is there, so we can imagine the situation that P inside and the P outside, P inside and the P outside in the that outside the artery is in the balance situation. Okay, so there is a proper opening could be there, as we have the different type of the lifestyle is there, and always we are just using the different types of the junk food is there, or the fatty food is there. So that food or the fat or the plaque comes that accumulate inside the wall of the artery, and a little bit the way of the blood is to be restricted. Okay, so as the way of the blood is restricted slowly, so it that it makes a little bit change in the pressure, as we are just applying this one concept. Okay, so somehow, if you are just getting not the proper way to the rushing of the blood is there, okay. So the heart having its own work, as the blockage are coming, so the heart is providing, so the blood is going to be stopped, but the heart is providing the blood with the higher velocity, because it having its pumping working. So whenever the blood rushes through this opening, so it's sudden its velocity increases in this portion. Okay, because the blockage are coming, so the work of the heart is to be provide the blood to the different part of the body, and as the velocity through this opening increases very fastly, so the internal pressure collapse. Okay, as the internal pressure collapse, so the outer pressure increases, which shrink the artery, and the proper that mean movement of the blood will be stopped through this opening. Okay, so it comes in the part of the heart attack we have. Okay, so this is the simplest method, as we are just using the simplest concept by Bernoulli principle. We have discussed that AV is equal to constant, that is, and the A is inversely proportional to the velocity is there. Same how we are just using PV is equal to constant, so we can say that the P is directly proportional to the velocity is there. So we are just using the simplest concept, velocity is higher, so the pressure will be the less. So the internal pressure collapse, as suddenly heart makes the too much higher pumping in the inner part of the artery is there. So the inner pressure collapse, and the outer pressure that very much high, so it close the or pressurize the artery in a such a manner that it completely blocks. Okay, and this situation is known as a heart attack. So this is the first application that is called the blood flow and heart attack we have. So here I have made the simplest statement: due to the accumulation of the plaque in the artery, the path of the blood flow restrict. So to fulfill the demand of the blood, the heart pushing the blood very fastly in artery, so the inside pressure collapse, and the P outside increases, in result the artery blocked, and that is called the heart attack we have. Now next term we have, that is called the dynamic lift. So what actually it is? So whenever we are just assuming dynamic lift, so it's a simply a upward force which arises on the different types of the object. What are they? As this is the feather we have, as already you have shown the very good shape. This is the aerofoil we have. Or you can imagine the wing of the aeroplane wing, or here I have also mentioned the some of the object that the ball is moving in the layers of the air. Okay, fluids. So all the time due to the movement of the objects or the shape of the objects are there, so the velocity quite increases or the decreases. So in the lower and the upper portion there is a pressure difference we have, and generally we are just using the word lift. So definitely the lower pressure is quite high as compared to the pressure on the upper part of a body. So this pressure difference lift the object in a upward, little bit upward direction, or it makes the little bit that mean helpful movement to be make that mean to move in a upward and a downward direction here. Here I have mentioned the ball which moving along the direction of the air. Here I have mentioned the ball which moving in a opposite to the direction of the air. Here I have mentioned these are the blades of the aeroplane. Okay, and these blades generally are made very much movable to make the movement of a helicopter in a downward direction as well as in the upward direction. So always we are just making the and then we are just finding the help of the air pressure in the surrounding. If you are not doing this one, so definitely it will damage our different types of the object. So the what is the dynamic lift? So same how it is a simply a upward force due to the pressure difference in a lower portion of a body and as well as the upper portion of a body. And simply we are just using the basic concept, that mean A is directly proportional to the pressure is inversely proportional to the 1 upon V. Same how the velocity is the max, so the pressure will be the minimum, as vice versa we have the velocity is the minimum, so the pressure will be the high. Okay, so how can we use that this concept for the movement of the different kind of the object in the air? So we will discuss here. Now here I have included the simplest define the dynamic lift is a kind of it is a force which act on an object like the aeroplane wings spinning ball by virtue of its motion through the fluid, as they are just making the movement through the fluid, so that these impacts are coming by the help of it this dynamic force, and by what manner it creates due to the pressure difference. Okay, so as the curve part of the ball and the lifting of a wing, and here we want to discuss the spinning of a ball, as the ball is moving in the layers of the air. So how this dynamic lift helps for spinning of its part. Okay, now here we are just assuming the first case in which we are just making the concept the ball moving without spin. So always whenever the players are playing the game of cricket, that means cricket, so always they are just using this scientific phenomena with them. So always it will be helpful to make the find out the best result in the bowling purpose also. Now here we are just assuming the little bit the leather ball is there, and we are just making the bowling. Now here we are just explaining the meaning of the ball moving without the spin. So what will happen? So as we are just assuming these are the movement of the layers of the air we have, or the fluids, the ball is moving in the fluid we have. Now suppose the ball is moving in the forward direction opposite to the direction of the layers of air. So same how we are just making the pressure, or we are just finding the pressure difference in the upper part and the lower part we have. See, same how the pressure difference is not available in the lower part as well as upper part. Now this one is the upper part pressure in the upper part, and this one is the pressure in the lower part. If both the pressure are the same, so there is a no possible movement or the spin if the ball is there. Okay, same how where the bowler is making no kind of the movement of the ball is there, so he just maintained the speed in quite a manner of the ball, so the upper and the lower half having the same pressure, so there is a no kind of the deviation of the ball. Now same how if you want to make the spin of a ball, so we must use the concept of the Bernoulli principle. Okay, Now if you want to make the spin of a ball, so same how it can make the spin. So we are just assuming the ball is moving that opposite to the direction of the velocity of the air is there. So here we have the velocity of the air, we have here we have the velocity of the ball is there. Both the velocities are in a different manner, so we are just making the little bit changes, that the pressure velocity is quite less, so the pressure will be the more in the upper side, and in the lower part we are just getting the velocity of the ball and the velocity of the air, that means both are in the same direction, so the velocity is quite high, so the pressure in the lower part is the minimum. So we can imagine the PU is greater than, that mean PL. So the little bit spin movement could be there. Okay. The curved path of the ball could be there. Okay. Pressure in the upper side is the higher as compared to the lower side. Okay. So the ball will make the curved path, or that mean a spin path. Okay. Same how some bowlers are making the reverse swing is there, so definitely they are just making the help of the air is there. Okay, so the captain is making the decision that some bowlers will make the bowling as in which the direction of the air is flowing. Okay, same how what will be the impact on the, that mean pressure difference, as we are just getting the velocity in the upper part, as we are just assuming the ball that making the movement along the direction of the air. Okay. So in the upper part the velocity is quite higher, so we have the pressure that is in the upper part, that is called the PU, and in the lower portion we have the less velocity, because both are in the opposite direction. So we are just getting the pressure in the lower part, that is called the PL, and definitely PL will greater than compared to the pressure in the upper part is there. Okay, so it will create the little bit bump in the air. Okay, same how little bit it quite make the upward movement, so definitely the curved motion of the ball or the spin motion of the ball in the air is called the dynamic lift is there, due to the concept of the dynamic lift, and dynamic lift arising due to the pressure difference. Okay, so this is the spinning of a ball, and always the bowler are using this one concept. So on behalf of this concept we have the Magnus effect. So what is the Magnus effect? The difference in the lateral pressure which causes the spinning of ball to take the curved path, which is this is called the Magnus effect we have. Now the next application we have the aerofoil, lift of an aircraft wing. So how it works? So generally we are just getting the shape of the aerofoil. So this is the kind of the shape of the aerofoil we have, and definitely whenever we are designing the aerofoils or the wings of the aeroplane airplanes, so the above surface which is very sharp, so due to the too much sharpen edge, sharpen surface is there, so the velocity will be the max in the upper part. Okay, so as the velocity max will be, so the pressure will be the minimum in that portion. Okay, and in the lower part we have the V minimum, so the pressure is the maximum, so it makes the little bit support to be lift the aircraft wing or the aerofoil in a upward direction. And same how you have seen the feathers of a birds, so whenever they are just making the upward motion or they are just flying, so they little bit need a pressure difference, that means lower pressure should be more as compared to the upper pressure. So their feathers are designed in such a way by the nature that in the upper portion that is generally the curved, and as the curved, so the velocity will be the maximum. Okay, so the pressure will be the minimum, and in the lower portion the V is minimum, so the pressure will be the max will be there. So due to the huge pressure difference in the upper and the lower portion, it will makes a little bit upward movement as it can easily the fly. Okay, now as well as we are just talking the lifting the movement of a aeroplane at a same place है ना. So, or we can say that the aeroplane having the special characteristics, it can be moved downward as it can be moved upward at a single place. Okay, so how it possible? Because generally used by the army. What is the purpose? That they have to be reach at a certain places where there is a no kind of the land is there. So on the mountain they have the make the movement in the downward and the upward directions, okay, at a single place. So where the Bernoulli concept is uses very fluently. So their blade are designed in a such a way कि उनकी ब्लेड्स को हम इस तरीके से डिज़ाइन करते हैं कि इनकी ब्लेड्स के जो मूवमेंट होते हैं वो फ्लोटिंग होते हैं. As we are just getting the blades in such a manner कि they are in a curved position. So generally we know the V max is there. So the pressure will be the minimum in the condition, and as the lower portion having the curved inward part, okay, so the pressure will be the max as the velocity is minimum. So same how it will make a suitable lift to a aeroplane wing is there कि जब भी उसे अपवर्ड मूवमेंट करना है तो उसे अपनी ब्लेड्स को कर्व्ड आउटवर्ड करना है अपर पोर्शन में और कर्व्ड इनवर्ड करना है लोअर पोर्शन में. सो देयर इज ए ह्यूज प्रेशर डिफरेंस दैट कम्स ऑन दिस ब्लेड एंड इट विल मेक द मूवमेंट ऑफ द ब्लेड विद द एयर प्रेशर इन अ अपवर्ड डायरेक्शन. ओके, नाउ एज द एरोप्लेन इज मेकिंग द लैंडिंग, सो डेफिनेटली हायर प्रेशर इज द मोर एंड द लोअर प्रेशर इज द मिनिमम. तो वो अपनी ब्लेड को किस तरीके से अरेंज करते हैं. नाउ द अपर पोर्शन विल बी द कर्व्ड इनवर्ड, कि अपर पोर्शन जो है वो कर्व्ड इनवर्ड पोजीशन के अंदर क्रिएट करना है. दिस वन इज द अपर पोर्शन वी हैव. ओके, कर्व्ड इनवर्ड होने के कारण वी मिनिमम रहेगा, तो प्रेशर अपर पोर्शन में मैक्स हो जाएगा एंड प्रेशर लोअर पोर्शन में मिनिमम होगा तो V क्या होगा, मैक्स होगा, क्योंकि कर्व्ड आउटवर्ड सरफेस जो है वो लोअर पोर्शन में है ना. द शेप ऑफ और द पोजीशन ऑफ द ब्लेड विल बी द इंटरचेंज. सो द मैक्स प्रेशर मैक्स दैट इज ऑन अ अपर प्लेट विल मेक द हेल्प टू ए हेलीकॉप्टर टू बी push downward with the concept of the air pressure. So always we should take the help of the environment, otherwise there is a huge pressure imbalance on the blade and it will destroy the wings of a aeroplane. Okay, so that's why the aeroplane is using this one concept very broadly and always it helps. Now dear students, one of the another application which I have added here, now blowing off the roofs during the windstorm. So as you have seen, there's so many slums are there. So when the wind storms are coming due to the huge pressure difference, so that definitely there is a huge loss in the slums are there. Okay, because they are living in a that mean kacha house, which we can say. So and generally they have the taper shape roof is there. So and in the hilly regions also we are just using this one concept. So same how it makes a very great that mean very huge disaster in this manner. So as we are just getting the curved shape of the roof, so on the curved shape of a roof we have the velocity of the air is the very fast. So as per the Bernoulli principle, pressure is the minimum we have. Okay, so and as we are just making the that mean knowledge of the pressure in the inner portion, so the velocity is the minimum, that is near about equal to the zero, and the in the lower portion of the roof there is a huge pressure is created, and definitely this inside pressure is max compared to the outside pressure. So little bit it helps the blowing of a roof in this during the windstorm is there. Okay, so definitely we are using a basic concept of the Bernoulli principle everywhere where we are just getting the pressure difference. Okay, so many applications we have discussed. Okay, so we should keep one of the interesting concept in our mind, that mean A is directly proportional to the P is inversely proportional to the velocity. Okay, this is the velocity we have, not it is a volume. Okay, you must keep this one inside your mind. Okay, same how we can go with the one of the NCERT question here also. Now dear students, here we have the two basic diagrams and the question number 10.15 we have. So here we have the two basic diagrams and the flow of the non-viscous incompressible liquid through a tube. Those having the different area of cross section we have. Okay, so by use of the concept of the Bernoulli principle, which one diagram is a correct and which one is diagram is incorrect we have. Okay, So here we are just using the concept that area is the more, so the pressure will be the more is there. So here we are just making the comparison in the diagram number A. Here the area of the cross section is the more, as we are just making the comparison of the level of a liquid inside the tube, and here we have the less area but the pressure is more is there. So this concept is not applicable suitably. Here we are just assuming the same thing, same approachable diagram is there. Little bit I have made the covering of the more sketch pen is there, okay, but you need not to be worried about it. These are the same on the same platform. Now the flow of a liquid is there, so the area of the opening is a large. So definitely if you're just comparing the tubes, both the tubes, so the level of the pressure will be the very high, so the water level will be reached at a greater height is there, okay. Same how here we are just getting the very right concept. Area of the opening is the small, so the pressure level inside the column of a liquid will be the less is there, okay. So this diagram is the very much correct. And there's the question number 10.15. so here we have discussed the so many concepts here. Those are based on the concept of a Bernoulli principle. So we have discussed the blood flow and heart attack, dynamic lift, spinning of a ball, aerofoil, lift of an aircraft wing. How the we are just using the concept of a that means Bernoulli principle in the different applications. So you must that mean do it inside your copy and just watch it. Okay, thank you.